So we have question number 10.5 and the question says कि in Young's double slit experiment using monochromatic light of wavelength lambda, the intensity of the light at point on the screen where path difference is lambda, right? So path difference is given lambda is k units. Okay, so the path difference for lambda wavelength is k units, right? What is the intensity of the light at a point where the path difference is lambda by 3? So the okay, so intensity that is given at lambda part difference is k. K is the intensity at lambda part difference. So it is asking that what is the intensity is going to be for lambda by 3 path difference if we going to take lambda by 3 as a part difference. Okay, so question is clear. Now let's try to solve this. So for that you have to know the formula for the intensity, and that is for bright fringe the intensity is I is equal to 4 I naught cos square phi by 2, and this phi is your phase difference, right? And the phase difference is going to be equal to 2 pi by lambda delta x, that is path difference, and path difference is dy by capital D, right? So that part difference is given here. You don't have to put this value. This value, the value for this particular term is given. That is for first case it is lambda, and in second case we have to take lambda by 3, right? So that is given. Okay. So now let's solve this question. So first of all, I have I is equal to 4 I naught cos square 2 pi by lambda into delta x, right? And for two cases we have two different delta x on which we have to find the intensity, right? So first of all I want to make you clear that what is this setup is. So as we know that there are two in Young's double slit experiment, we take one source and from there we take two cardboards, cardboard 1 and cardboard 2, and we do two holes. From there the one source, the light coming from one source act as two source, right? Because I have now two cuts from their light is coming out. So this is the place where we get the central maxima, and there are so many positions where we get other maximas, right? So for every maxima I have a value of intensity, and that value is generally written as I is equal to 4 I naught cos square phi del phi by 2, right? So like this way in general the intensity is written for every bright fringe. Okay, so now that d in you have seen that phi is phase difference. We have 2 pi by lambda delta x, and this delta x is going to be your d small d y by d. So this capital D is the distance between this board, this small d is the distance between these two sources, sources that the cuts, and the y that is given here is the distance between the fringe that we are talking about to the brightest fringe that we have in the center, right? And then this lambda is the lambda that is used for the wavelength of light that we have used, and this is constant 2 pi, right? So this all setup you have cleared. Now you can see it more clearly that what is happening here. So now intensity for part difference del x is equal to lambda that is given. So what is the intensity for that? So phi is equal to 2 pi by lambda into del x, that is lambda given. So 2 pi is going to be del x del phi, that is phase difference. Then I is equal to 4 I naught cos square pi is equal to 4 I naught, right? Simple. We have put the value here, that is for phi by 2. So I got the value of pi for phi by 2, right? And that intensity for the case of del x is equal to lambda is 4 I naught, right? Now we have to compare that. It is given that when we have taken the lambda as a part difference, the value of intensity is k. So I have put the value here. As you can see, we have put the value of 4 I naught is equal to k for phase difference, part difference lambda, and now I naught is equal to k by 4, and this we are using to again when we are solving the second case, that is del x is equal to pi by 3, right? So del x equal to del phi is equal to, that is phase difference is 2 pi by lambda into lambda by 3, that is path difference for this case. and we got 2 pi by 3, right? So del phi by 2 is equal to pi by 3. Okay, and after that, after putting that value, we got I is equal to 4 I naught cos square pi by 3, and I is equal to 4 I naught 1 by 2 square, and I is equal to 4 I naught into 1 by 4 I naught, right? So this way we got the value, and now as we know that I naught is equal to, we have I naught, the value of I naught is k by 4, so we have to just put the value of I naught here. So I naught is equal to k by 4. Hence the intensity for delta x is equal to lambda by 3. When we take that path difference, we got I is equal to k by 4, right? So this is the simple case and the solution of this question. You can see the solution, and it is very simple.